brief of what we are doing, he gave the statements. We are not short of water, we are short of storage. At that time, I'm being a water resources engineer, all the time talking about shortage of water, I was shocked for a moment to receive this message. And now, when I go back, I start thinking a bit, what he say is true. In Malaysia, we only hardly use 3% of the God giving to us. The rest are wasting to the sea. And yet, all the planner, the government are saying that we are short of water. So in fact, the statement of we are not short of water, we are short of storage is the true facts. Yeah. So, and I like the words that Professor Sitaram and Kumashanti is putting up, that India is not India is not running short of water, but the water is running out of India. So that statement is in fact very, very quick. People will capture what it means. So this is the true facts. Yeah. And for that reason, after the 3 years ago, I went purposely to Australia to sign the MOU with Prof. Yang to promote this coastal reservoir in Malaysia. I call myself a promoter, a strong promoter of coastal reservoir. And we have been working very hard with government Malaysia. And for the first time in last year, through our effort, Malaysia government had put in all of their raw water resources development plan to consider coastal reservoir is one of the options. And at the beginning of this year, they have actually cancelled one dam project, which is already the land acquisition already proceeded. But the government decided to cancel the dams project and looking into this option. And at the beginning of the year, March, we, through the effort of Prof. Sitaram, myself, and Prof. Yang, we have established the International Association of Coastal Reservoir Research. And we are going to announce and inaugurate this in this August at the International Association of Hydraulic Research Conference in KL. And we welcome all of you become of the members of this association. The idea of the association is to gather all the experts from various fields, to put up their mind and share across the world to make it happen. Yeah, next. So I'm going to share with you some of the site visit that I went during this year's to Shanghai. Because during last year when I promote this concept to Malaysia governments, we have been talking about the Shanghai, the Qingchaosha Reservoir, and physically I was not visited, so I wanted so badly. So this year, I make an effort to visit the Shanghai, the reservoir, 3 times. One time in March and 2 times in May. Yeah. Go straight to the presentation. Next, please. Oh yeah, just click the cancel. Okay, this is a write-up by the Professor Yang about the coastal reservoir. And in fact, the Shanghai coastal reservoir was actually the basic idea is developed from Prof. Yang's idea that he has presented just now. And we are talking about so many has been done. And now India is a time to develop one. Start with this. So I will go concentrate on the Qingchaosha Reservoir. This reservoir is completed in 2011. Is now supplying water to 15 million, 60% of the Shanghai population. Just one single reservoir. And this is from the Google image. Here you can see this is the Qingchaosha Reservoir, where the alignment of this is a dike, you can see, and this is the islands. And the Shanghai city is just opposite it. And you can see very obviously the turbid water and the clear water within the reservoir, clean water. And this is from the view from the overall, and you can see this is the reservoir. So it will be amazing for the initial people to understand how can you harvest fresh water at the estuary, at the river mouth, just front door of the sea. So in fact, this reservoir before they're being put into the physical completed in 2011, they have spent many years to do the research, almost 10 years. And they have studied and they found out that in fact, with the very large river of Yangtze River, most of the time you have fresh water at this point. So they have found out that actually throughout the years, only 60 days they cannot open gate to receive the fresh water. The rest of the 300 days, the fresh water actually arrives to their doorstep. They just open the gate and receive it. Yeah. So this is so for every river there is a unique by itself. So we need to do a proper study to study the saline profile and things like that. So that can be done, not an issue. And this is a schematic diagrams of that reservoir, where intake of this water is about 200 meter cube per second. Huge amount of water coming in. And you can see from here, this is the intake and this is the outlet. This is the reservoir. The storage is about 400 over million cubic meters. Yeah, the depth for here is varies from 5 to 11 meter at the deepest point, close to 20 meter at the intake. And from there, the intake point is applying the raw water to two diameters, 5.6 meter diameters submarine pipeline across the river to supply the water to the treatment plant. Yeah. And this is myself. We're standing on on the side on top of the dike, looking toward the sea, the Yangtze River. This is where we're standing on the top of the embankment, where it's actually a proper access, road access. And this is the designer, which happened to be the Prof. Young's classmate also. And these ladies also will be attending the August conference, where we can we can have a detailed discussion with them on that. And we also met the operator to understand what is the problem since their operation in 2011. You know, what is the operation procedures and what is the problem that they are facing. And you can see that this is on top of the access. We are driving on top of the dike with a car to visit the dike from one end to another end, about 20 kilometers. You can see the size of the reservoir. The surface area is 70 kilometers square. The surface area of the reservoir, right? So, and also they have placed the solar panel to power up their own lighting, and also the wind power, you know, for the electrical demand here. So you're looking at this side. Is the river side. So the dike is just merely a simple, you can see, quite a simple, straightforward CNS structure, where they have this for breaking the wave. And this is the second tier. Of course, the foundation is there, right? And this is on the reservoir view. You can see beautiful water compared to the turbid water and the other side. And this is the type of structure they are putting up. It's a rebatments at the bottom. Yeah. And this is another view showing some of the maintenance work that are putting up the rubbish, collecting the rubbish. And this is another view, beautiful view in the evening, with the imagine you have this kind of reservoir in front of your shoreline. Yeah, beautiful. And here also they're starting to put back some of the sand in order to put planting some wetland. So otherwise it looks like very too rigid. So now there's stage 2 of the project. They are going to enhance the area by wetland plantation. Yeah, and this is another view showing the area. And this is the embankment typical design of that embankment, where they're actually cut off the salt water intrusion. This is one of the things that you have to consider during the design to prevent the salt water from the sea that coming into your freshwater reservoir. So they're actually putting in this pressure grouting. So there are many methods you can adopt. Yeah, this is what they have used in the Shanghai. We're using the pressure grouting to form a barrier to prevent the salt water from intrude into the freshwater reservoir. And this is a monitoring station for chlorine, because they want to make sure that the chlorine level, the salinity, is below the acceptance level for the freshwater demand. So there are a series of these real-time monitoring stations being installed along the rivers. So this transmit the data into the control station, and they will open the gate when they found that the water quality is within their limit. So things like that have to be built into the system. Like what Prof. Yang has said, we got a choice. We receive the good water and bad water directly charged to the sea, and that bad water actually is a food for the fish. So it is we have to ensure that. And this is a slide showing the membrane geotextile bag that they use. So they actually pump out the sand, because to form the reservoir, you need to dredge the reservoir. So that material, they actually pump it to this bag, and that the liquid come out, and they form this jaw bag, a big jaw bag, big huge size to form the foundation. So this is the hose of that jaw bag where the water will be pumping in, and to form that jaw bag. And this is another view of the intake structure at the this reservoir, where they have the monitoring station to monitor the real-time monitoring station for the water quality. So they they actually test for a full series of the water quality parameters, come to about 64 parameters. And this is a gate that they install for discharging the water. One of the very important parameter during the design is the detention times of this flow water. You must make sure that the reservoir have the free moving water. The water is moving. So one of the problem that they are facing now is at certain edge of the area, they are facing some algae problem, where at the edges the velocity are slow when the level are shallow. So they have this problem especially during the dry season. They have this algae. So these are the important factor that we must consider during our design. Yeah. And this is another view of the intake, where they have a lot of gates open for the intake water to come in. And this is another view. So, and then for that reason, because they have the experience and research for the past 10 years and design experience, I myself have signed an MOU with this designer, so that they will support us in wherever we go to promote our coastal reservoir. So if you need any support from our team, that is ready. We have already got the team to be for you. Yeah. So thank you for this is all my sharing. Yeah. Thanks.
Thank you, sir. So now I request Professor K.B. Anand to hand over a memento as a token of affection from Amrita. Please. Now I request Dr. Lingaraju to make the presentation on river rejuvenation of Netravati River.
Dr. Lingaraju is an authority on the river rejuvenation. Throughout his life he has worked on this. Okay? And earlier he was an expert on the groundwater, and he was the initial campaign was drilling borewells. But now he says no more. So that's the way he has come through. Presently he is with Art of Living with a large team working on river rejuvenation, and I'm very proud to say Vedavati River in the state of Karnataka, he has already been successfully rejuvenated, and water is started flowing in some sections of river Vedavati. With these brief remarks, Doctor.
Thank you, Dr. Sitaram. It is really something that all the team here is doing to come out of all the known problems of our efforts to store water on the surface, maybe dams or anything on this. But the concept of coastal dam, definitely it will solve many problems. But we have to think of the very main source. Going to the issue of rainfall, we are finding a lot of difference in the rainfall, but total volume of water that we are receiving is the same since many decades. But we could see some changes of intensity, distribution, etc. So if we can just think over why such a change has happened, it is all due to the land use changes that we have made since 3-4 decades. There is variation in the temperature, pressure, and the rainfall distribution is also getting varied. So if we like that, if we can go back, even after we build the coastal dam, should we not think of the health of the river system, which is the source for the coastal dam? And many of you, I saw even in the last seminar in Bangalore, you have analyzed a lot of the changes in the land use and reduction in the flows, siltation problems, and the change in the natural vegetation, etc. So this is an indication that we have to take care of the river's health itself. So when we talk of the Netravati, I have been working since 3 to 4 decades. I was an engineering geologist in an hydroelectric project there, Varahi project. And I was a mineral exploration geologist camping in Puttur and the Subramania forest area, where I could see ample water at that time. Everywhere there was water, with similar rains. And I worked for a long period in the groundwater field, where I could see a lot of changes during my service. In a matter of 3 decades, we were very proud of in the beginning to explore groundwater and tell that every farmer has his own water source in his own field like that. And we had thought of, even it is a fact also, it is we are more dependent on the groundwater. And somewhere there was a gap in understanding the relationship between the surface water and the groundwater. We never thought how this groundwater gets replenished. Simply went on exploiting, the technologies improved from open wells to bore wells and deep bore wells. And that renewability is being lost. So that made us, and also the technological improvement from the space made us to analyze properly, because the remote sensing is like an eye in the sky, which connects also, it gives a synoptic view of what is happening from time to time, the repeated images also. So that made us to think of what is the problem with the river getting dried up. Many perennial rivers are becoming seasonal, and seasonal are getting dried up. So since 4 years, we have been working on how to bring back that original, or just we should go back at least 40 years, where there was sufficient water. Even after the rain stops, the streams were flowing and the water bodies had some water at least, but it is permanently becoming scarce. Even in spite of heavy rains, we are not seeing the sustained flows in the streams. So the concept of river rejuvenation is to bring back the natural processes that were operating. It is not much engineering there. The nature had its own integrated water resource management. The rainfall, the surface water, groundwater, the water in the vegetation and in the space. All were connected, and that's how water is considered as a renewable resource. That renewability is decreasing. So how to bring back that cyclicity as a normal thing? That is where we have to honor nature, copy nature. What nature had been doing, that we have to replicate. That is the concept of river rejuvenation. I will go through a few slides. Since 4 years we have been able to work in several river basins across the country also, and wherever we have done the work is bringing more confidence in us. With minimum cost we will be able to provide water to the farmers and drinking water especially. So in the context of coastal dam, I thank Professor Sitaram for inviting me. This I was not knowing at all, this technology and all that, but really it is required. Several types of interventions are required to make the water available, and this is one effort. So when he is thinking of putting a coastal dam across Netravati, we have to just find out what is the scenario, geohydrological scenario, what is the type of aquifers, what are the type of soils, all that lot of work already your team has already been done. But should we also think of rejuvenating at a micro level? They say river is not just a course of water. It is a network of streams, and this network of streams is an area also where the water catches and flows. And I always compare this to a living system, and these streams are like nervous systems which carry the water everywhere, not only space wise, even subsurface, and there is a linkage between the surface and subsurface. Somewhere the surface water will go down and become a spring, or it again comes back as a surface water. That wave-like movement in the whole geohydrological scenario can keep the river alive. That is what I want. Before launching any water harvesting big projects, we have to think of the health of the river. So we have to study the anatomy and physiology of the river, and then treat then and there so that it becomes sustainable. This is all I need not explain. You have done much more work than me, and we are into presently we are into drying up rivers in the plain area, and of course we have to do this even if we have to have water either through the Ethinole or any other, even the coastal dam. So it is interesting, and I am really happy to participate in this project. All this detailed mapping you have made, but here what I say is the entire area can be divided into mini and micro watersheds, and we can classify. There are some of them are forest watersheds, some are urban watersheds, some are agricultural watersheds, like that. There we have to find out what is the scenario, what changes are occurring. This is what I told you. There is connection between the surface and subsurface, and this we are all aware of this big hydrological cycle from sea to the sky and then back to the land. Such microcycles are also there in each watershed. In each watershed there is cyclicity. There is vegetation cover, there is surface water, there is groundwater. That if all the microcycles can operate, then the regional cycles can operate also. Even the climate change we are bothered about is also addressed. So this is we have to harvest water and reduce the rate of runoff. See, the land use changes that are occurring. See, natural forests have been converted into monocropping. Lot of plantations we are seeing there. Either it could be coffee or rubber, tea, So this kind of man-made changes on the land will also change the hydrology or the hydrogeology of that area. The water which can just stay there, the residence time of the water on the land is becoming shorter and shorter. So there is a methodology. It is well accepted methodology. Lot of work has been done in ISRO. I was associated with the ISRO for this project to coordinate with the state, and we have Dr. S.K. Subramaniam who was very much in charge of this, and we had been working, and now he is with us to advise this kind of projects. This is the scenario which we have to understand. We have to reduce the runoff rate. That is only possible by the natural vegetation. But because we have reduced the natural vegetation, we have to go do some artificial works. There Sitaram comes into picture also. See, we have to reduce the runoff. So there we are going for what are called as Boulder Checks in the plain area. Maybe with different designs, the steeper drainages will have to design a little more relevant designs and for the harvesting water and recharging groundwater, so that it will slowly come towards coast. These are the boulder checks that we are doing, and this will not stop the water, but it will reduce the rate of runoff and also increases the soil moisture. So what is happening is there will be heavy rains, but tomorrow or day after there will be no water there at all. So there is no scope for retention of the soil moisture, which will make the vegetation suffer. And we need to put the water a little below, because the surface, the skin of the land is thin soil cover, which will not be that permeable. So that we have to artificially put that water below the soil and fill the aquifers. They are nothing but weathered rocks, porous rocks, which are the aquifers, which can hold more water than any of our surface reservoirs. That has to be saturated, and there it keeps flowing and springing up. In the lower altitude, the streams will remain flowing even during summer. And in the plain area, we have many water bodies. These water bodies, the tanks that our ancestors have built are getting dried up. They have become evaporation pans because the storage capacity is reduced by the siltation, and the water that was being pooled is becoming a sheet of water, and it is being exposed due to the sun and wind. It evaporates the water back to the sky rather than putting it below the surface, and in the downstream that base flow will not be there. So then the main permanent solution is the natural vegetation. Even in the Netravati basin, we can see a lot of land use changes. That has to be wisely. Maybe we cannot say farmers to go for plantations, but what kind of plantations can copy nature, what natural vegetation makes it, that kind of changes that we will have to bring back. Thank you.
All of you agree with me, this is going to marry with the the proposal of coastal reservoirs. We'll have more water flow through his work, maybe another 10-15 years. So that's why attacking the root cause of the problem at the top of the hills, that's what Dr. Lingaraju is doing. We are also giving some of the geotechnology. It's like subsurface dams, subsurface dikes. In addition to the...
I forgot to tell, even Prahlad was there with us. We traversed in the Madkeri area, where the runoff is so fast, and there is no drinking water in Madkeri. Means what is the issue?
Madkeri is actually...
And they are going for bore wells.
The rainfall is 6,000 millimeter average. This is in the Western Ghats. Little up north in the same hills.
If you permit me, I would like to give a good news to the Tamil Nadu people. Since Sunday, because Professor Subra was talking about the Tamil Nadu issue. Since Sunday morning, we have been traversing across the rivers of Tamil Nadu. And we are seeing, surprisingly, that one Peyaru, is it? Peyaru. They say it is a ghost river. There will be runoff fast morning, after a few days after the river flows, there will be no water. Because of the geomorphological changes, then there is thick sand there. So then I remembered Sitaram, we have to bring him. Because this, the people know about only check dams, but there are several designs which we can store on the surface and below the surface also. We can't store. Water is the one thing which will never stay anywhere. If it stays, it creates problems.
Very rightly said, sir.
Yeah. So, what is happening in nature? It is cyclic. That's why it is a renewable resource. We should not stop it, but we should make it available through the year. Till next rain comes, there should be movement of water on the surface and subsurface. So that is why these designs, geotechnological designs, will help us, because we can't create forest overnight. See, it is difficult, but we are losing forest wealth that also we have to be aware of, and we should see that the forest comes back, so that we should keep the soil moisture retained. So that way, in this whole coastal dam project, one component of rejuvenating the river has to be addressed, and it has to start from now only. Thank you.